Hello and welcome to DTANM. Today I'm going to walk you through what you need to know to participate in a competition. The first thing you'll want to do is go to the URL your administrators provided you. For me that's hack.d.umn.edu. Once you're there, you'll want to log in with the username and password they've given you. And the first thing you'll want to do then is to change that auto-generated password. You wouldn't want anybody from any other teams logging in as you. With that out of the way, the next thing we'll want to do is take a look at our agenda that we have here. So the first thing we do is take a look at the documentation on what we're supposed to do in our challenge. For this, we're doing a simplified demo of the Echo program, similar to what you'd find in bin echo on your Linux machine. We have a little bit of information on what's going on here on the game, on what you're expected to fix, the desired behavior of your program, and the gold standard for you to compare against. After you've read through this information, which will of course be different as you're likely doing a different challenge, you should take a look at the next step, which is downloading your code. So for that, we go to the Submit Program page and we find our instructions. And all that is a simple git clone. So I'm going to go ahead and do that. And for me, that is a git clone hack.d.umn.edu/program. And then our destination, which for me, I'm going to put it in a directory called Echo. And I will be prompted for my username, which is my email, and my password, which I've just changed. So now let's take a look at what we have. So I have two files here in this directory, an echo.c, which is our program, and a makefile used to make our program. The makefile is very simple, and it only has two instructions: a compilation step to build our executable, and a clean step to remove all the extra things that were generated along the way. Our echo is only slightly more complicated, and what this does is it creates a buffer. It iterates through that buffer and zeroes it out, since the C standard doesn't guarantee that to happen. It goes through, iterates through our arguments, and copies them into that buffer. If it is not the last argument, it adds a space. We don't want a trailing space. And then after that is done for each argument, we print the buffer. Simple enough. Let's try making that. That's done. Let's demonstrate that it works, at least in some limited cases. We'll pass it a few arguments. Fantastic. It echoes just like we'd expect. How might we make this break? Well, let's try passing in, say, 20 arguments. Well, we see it gives a segfault. For comparison, if I run my local bin echo, that works as expected, passing through all the arguments. But we don't. We have a segmentation fault. So let's fix that bug. So, looking at this program, I see that there's a 32-character buffer. Likely, that's what's causing us our problems. So, in lieu of an actual fix, for time's sake, I'm just going to increase the size of this buffer. Make it, say, 128 characters. This will allow us to do more echoes, though it will still break at some point. Ideally, this should be fixed by not using a buffer at all and just iterating through the arguments in place and printing them out individually. So, if we make that, and then run our echo again. Fantastic. That works exactly as we'd expect. So let's commit those changes. And push those changes up. You'll notice it'll ask me for my username and password again, which I will provide. If you don't want to provide these every time, because that can become a little tedious, there are instructions on how to cache your password. You can simply run this credential helper cache command here, or read a little bit more on it in Git's documentation. Anyway, if we see our original push had been initial commit at this commit hash, if we refresh the page, Now we see that our increased buffer size has gone to be scored. So we can go ahead and check our score, but there are no attacks yet. No one submitted any. So we have an attack that we can submit. Let's go ahead and do that. So we go to attacks and submit an attack, or equivalently submit an attack on the menu. We'll give our attack a name, which would be buffer overflow for this one. The names can be descriptive, but don't have to be. And we'll pass it some arguments. So for this, we just want at least 32 characters. I'll give it 40. So there's 40 characters. We don't need any standard input, we don't need any environment variables, and we don't need any files passed in the same directory. So we're good to go. Let's create this attack. Fantastic, we've done it. Let's take a look at what we've created. We have the argument passed in here, and nothing else that was passed to that. We notice no teams are listed as currently passing or failing. There are currently 2 teams participating, us and the other team. But neither of them are listed here. That's because the scoring hasn't happened yet. But if we check back in a little bit, we'll probably see that our team will have scored. Hopefully, we'll be passing this. And the other team will have scored. Hopefully, they won't. So we can see we are, in fact, passing. We can see the same thing going to look at our score. We see that we're passing. If we go to team rankings, we can see that we're passing 1 out of 1 attack, and that the other team is not. We can drill in a little bit more and take a look. What are they doing? They were expecting to see this output on standard out, and instead they received segmentation fault, core dumped. Okay, so we know the issue they were having. And really, that's all there is to it. Now we see we have successfully outscored the other team, we are leading, and we have submitted and fixed a bug in our program.